Hi, my name is Jan Wilczek from WolfSound.com. Welcome to WolfTalk, a podcast about audio programming. In this podcast, you will learn how to build your career in programming or research related to audio, meet programmers and researchers from all around the world, and learn about the intricacies of sound. Hi everyone, and welcome to the 29th episode of the WolfTalk podcast. Today, as usual, I have a very special guest for you, namely Victor Zappi, an assistant professor of music technology at Northeastern University. He's also a researcher on music instrument design and audio in general. So with Victor, it's a very interesting story because we met at the DAFIX conference in Surrey in 2024, where we immediately connected over Victor's conference paper on running neural networks on Android devices. With my background on Android audio apps programming, I was really interested in what he's doing, and it turned out that he actually used one of my tutorials in one of his previous papers. So it was really, really cool. So Victor, apart from his research, develops the LDSP C++ framework, which allows you low-level audio device control on rooted Android devices. But he also does other cool stuff on digital musical instrument design. For example, he designed the Hyper Drumhead, which is kind of a 2D touchscreen that you can interact with to create music, and it runs on a huge number of GPUs. I mean, Victor will tell you more about it in the episode. And finally, I wanted just to mention that Victor is also a developer of the Bela hardware platform. It is a hardware platform that allows you to easily create an audio device out of existing blocks, and it actually, I believe, found its way into commercial applications as well. But it's a very interesting platform developed at Queen Mary University, London. Okay, so what we'll talk about in this interview is we'll talk about Victor's career. We'll talk also about how to learn DSP in general, digital signal processing, how to process sound with software. We'll also talk about how to create your own digital musical instruments and lots more interesting stuff. So if you're interested in the details, be sure to check out the episode notes at thewolfsound.com/talk029. Once again, it's thewolfsound.com/talk029. And now, let me present to you Victor Zappi. Hi, Victor. Thanks for agreeing on this interview. Could you introduce yourself to the audience?
Sure. My name is Victor Zappi. I typically say that I'm an engineer and a musician. Right now, I'm an assistant professor of music technology at Northeastern University, where I teach and do research on musical instrument design, but also in general on audio.
Okay, awesome. And we'll definitely get into more details on each of these topics. But for now, for starters, I wanted to ask you, how did your interest in music start? So were you playing a musical instrument?
All right. So not necessarily, in the sense that I was making music not by playing musical instruments at the beginning. I was playing in bands or singing in bands, like underground music scene, my local town. And then I started incorporating electronics into it. So that was my first experience with musical instruments. Like, people sometimes don't consider electronics a musical instrument. And of course, I played a lot of music with my computer at the time. So my exposure to music was very DIY in a sense, or self-taught.
Okay. And can you still remember which, tools or programs did you use back in the early days?
Absolutely, yes. So I spent a lot of time on what is now called FL Studio, which used to be called Fruity Loops. I don't remember if it's loops or loop. Then I switched to Ableton Live, so that is more. No need to remember that, right? Everyone remembers that. Before that, actually, my first experiences happened on a piece of software called EJ Music something. I was doing some hip hop at the time. It was kind of popular, but it was not very professional. FL Studio was actually pretty good already at the time. And I'm talking about, what was that, like 2003, 2004. So despite, how many years? So many years, too many years, but it was good already. Yeah, it was already good. Anyway, yeah, these were the tools that I started using.
Okay, nice. So did this interest in music kind of led you to what you studied at the university?
No. I was I was into engineering. I was interested into knowing how, in general, electronics work. I was curious, but also I was pushed by my family to pursue a career that would have become a job, basically, to land a job eventually. Nothing against philosophy, but it was more difficult to find a job with a philosophy degree at a time in my town. Engineering and medical school were the ones that were basically more secure in a sense. That's why I pursued that career. But eventually they merged because I started using or gaining skills that were easily transferable to pieces of software and also hardware that I was using to make music. And I realized that those kind of skills were helping me out, were giving me knowledge that other people didn't have in my musical entourage. And so eventually, after a few years, the two paths became one.
Okay, awesome. So can you tell maybe, so you studied computer science, is it correct, or something similar?
I actually started, I have a bachelor and a master's degree in computer engineering, electrical and computer engineering to be precise. And I did my PhD in computer science.
Okay. So if you studied electrical engineering, did you also have like digital signal processing courses?
Yes, not audio, but yes. Yeah. Like Fourier theory and communication, a little bit of communication theory. Sure. And yes, so there's some overlap in there for sure. So filters also, it was difficult at the beginning to make a connection between all these equations that describe filters behavior and digital analog filters and what I was using in digital audio workstations, but eventually clicked.
Yeah, so but now you're then all the more well-equipped to help your students bridge the same gap, right?
That's a very, very good point. That's exactly what I do. I teach everything through the lens of audio and music. So all the engineering that I teach, which is a lot, is through that. So yes, I try to make that switch easy to make them click together more easily for students.
Awesome. And can you share what was your PhD about?
Yes. So my PhD was officially in virtual reality, so a part of human-computer interaction. So not just designing virtual reality experiences, but also studying how people behave within these virtual environments. But I had a very forward-thinking supervisor that allowed me to actually focus on how music is experienced in virtual reality. And actually, that was when the two paths became one during my PhD. So it was about HCI, virtual reality, with a little bit of engineering, of course, sprinkled on top. But then really focusing about making music or even, listening to music. Rather than listening, I would say experiencing music in virtual reality.
Okay. And did this kind of, spark you, like pushed you into this way? Okay, I want to really combine, music and computer science. Okay. And then what were your steps after the PhD? Did you want to continue in the virtual reality direction?
Well, rather than considering virtual reality and music as a direction, I was more into what does it mean to have a PhD? What is my role as a PhD, as a person who is a PhD, who has a PhD, right? So not necessarily the topic itself, but the role. And towards the end of my PhD, I realized that I wanted to become a professor, to teach students and continue doing research. And of course, I was really interested into the combination of technology and music. So I was very open. And in fact, my career, the following paths of my career were kind of all over the place in a sense, and still are. So yeah, more about the role rather than the field.
Okay, so what were your then next steps then in this exploration?
So the next step was to find a job that I liked that could be the first step towards becoming a professor. Because becoming a professor, I was aware that it would have been a very long pathway. So I was lucky enough to move to France in Paris and join the IRCAM, the Sound and Music Movement Introduction team. That was a short experience for me, but fantastic. I was between research and development there for a project that was really in line with my PhD. It was what we would call now audio first virtual reality. Mm-hmm. So working with virtual environments that manifest themselves only through sound and music rather than to visual output. And I knew these people from before. During my PhD, I published in conferences and attended symposia and workshops. And so some of these professors and coworkers eventually were there. And when the opening became available, I was lucky enough to be selected. And then after that, I managed to even reinforce my academic path, because then I landed a postdoctoral position. That was more, as I said, development / research, right? Well, when I moved to London to the Center for Digital Music at NIME University, that was really a fully fledged postdoc as part of a project that was funded by the UK government. So I was really 100% into the academic pathway at that point.
Let's pause here for a moment. Victor Zappi is the creator of the LDSP C++ framework for audio device control on Android phones. But to create audio apps on Android, you would probably use the JUCE C++ framework. What is JUCE? It is an open source, cross-platform C++ application development framework that makes it easy to create audio software as well as audio plugins and plugin hosts. You can write code once and build VST, AU, AUV3, AX, and LV2 plugins on Windows, macOS, iOS, Android, and Linux, as well as embedded platforms. I've been successfully using JUCE since 2018, both in my private and professional projects, so I'm delighted that they're sponsoring the podcast. I especially like how JUCE makes it easy for beginners to jump right into creating audio plugins and applications without worrying about C++ quirks. JUCE is used by the majority of the world's most important audio companies, but it is free for personal use, and there's affordable pricing available for companies just starting out. Apart from the framework itself, JUCE has an amazing community of users gathered in the JUCE forum, which is a great resource to learn audio programming on its own. Most recently, the JUCE team has released JUCE version 8, which contains many new features, including WebView plugin UIs, which is very exciting. To start using JUCE now, go to juice.com, download JUCE, and follow their Getting Started guide. I've also put a link to it in the description. Have fun creating audio apps and plugins. And now, back to the interview with Victor. Okay, and so can you share what were your duties there? And what was the project about?
Yes, the project was called Hackable Instruments. And I was working under Professor Andrew McPherson, who was not just a former supervisor, but also a very good friend. We did a lot of things together. And I'm very grateful to what he taught me and the possibilities that he gave. And basically, the idea was to approach the development of musical instruments, digital musical instruments, from a different perspective. Specifically, many of the digital technologies that are used inside of musical instruments nowadays are kind of black boxes. You are not supposed to modify them, either hardware or software. If you try to modify them, probably you break them. And this poses big limitations on how people can appropriate an instrument or also continue the development of an instrument, especially as opposed to traditional musical instruments like acoustic ones or even electric ones. Can you imagine like a guitar? What if a guitar we were not given the possibility to change the number of strings on a guitar or modify the body of the guitar? What if it was since day one a fixed design? Well, probably it wouldn't be as popular as it is today, right? It went through so many iterations, through so many hands, and then we got something today that is very well accepted and successful, I would say. With digital musical instruments, this longevity and development is sometimes not there. I would say most of the times is not there because of these design approaches. So the idea was, how can we reverse this paradigm? Mm-hmm. How can we make digital technologies more open, more modifiable, and what is the appropriation outcome that we may see when we provide these technologies, these instruments to performers, musicians, composers, and whatsoever. So anyone who is interested in making music with them. And so we started developing some instruments through this lens, which was very difficult at the beginning. We had to come up with technologies that would allow everyone actually to put their hands in the system without breaking it.
Okay. And can you maybe expand on the term appropriation? Because I went through your research and I maybe did not go into that much effort to look it up in the dictionary. But could you maybe elaborate on what exactly this word means, in the context of digital musical instruments?
Absolutely. Yeah. In general, appropriation is something that happens, is a phenomenon that happens whenever we interface with objects, regardless of the nature of those objects. A very simple example of appropriation is customization. We start, putting stickers on our objects or coloring them or adding some gadgets, or even removing parts sometimes. We don't like maybe we wear glasses and glasses came with a little fidgety thing that we don't like. We will remove it, right? Because it doesn't feel good for us. And so this is the first step towards the appropriation of an object. So making this object more of something that is, that belongs to us, that is not the same as the same object that another person bought. So we start to make it unique. And then it goes beyond that. It goes towards how we use this object, the way we use it. Are we using it the way it is supposed to be used? Or did we come up with a new way of interpreting, let's say, their affordances, right? So what the object is supposed to be provide as a usable information, right? What kind of actions I can carry out with this object. And this is super strong in the case of musical instruments. There are very open affordances that are very clear. So we are supposed to press these keys and press these frets and hold the guitar in a certain way, or sit at the piano in a certain way and hold the saxophone in a certain way. And then there is also this extra step that we can add to the interpretation of affordances. Even the modification of the physical body of an instrument to change the affordances, to maybe discover new affordances, right? Maybe if you think about John Cage and the prepared piano, we can put stuff into the strings of the piano, right? Which you're not supposed to do. You can remove the lid. You can really misuse this piano to obtain very interesting sounds and new compositions and new ways of making music with it. So appropriation goes from customization down to complete reorganization, maybe also breakage in the sense of the instrument, to turn it into something that is unique, that you make music with, and no other people are able to, basically.
Okay, I see how this term is very closely intertwined with the idea of hackable instruments.
Yes.
So in the same spirit, you mentioned that you were working, you needed to solve hardware and software challenges. So I imagine in this context, you kind of also worked on the Bela platform, which you co-created. So I guess that a lot of podcast listeners have heard about it, but I guess as usual with any kind of technology, most of them haven't. So could you please explain what is Bela?
Absolutely. Bela basically was, as you mentioned, the technology that allowed us to create instruments that could be modified and hacked. And Bela is basically right now a development platform. So it's part hardware and part software, firmware. And the idea is that people can use it as the Arduino for sound and music. Mm-hmm. So you connect it to your computer, you use a framework to develop your audio applications that can leverage these very specific features that the hardware and the software are characterized by. Specifically, one of the main features of Bela is this ultra-low latency. It was probably the first official product that harnessed this terminology, which means that the time between action to sound is very, very short, it's possibly less than 1 millisecond in many settings, it's completely different than how digital musical instruments work when they rely on MIDI, USB connections, and when there is a laptop involved. Typically, we talk about 5 milliseconds of latency between action and sound, even more. And then there's latency changes over time. There is some kind of jitter. And in Bela, we were able to really minimize both latency and jitter to make the experience more similar to what we experience when we put our hands on an acoustic musical instrument. We expect almost an immediate response to our actions. And beyond that, Bela also has these built-in features to communicate with the outside world in terms of sensor reading, but also voltage output that we can use to drive actuators, for example, or lights. And everything, again, is very responsive and is synchronized with the audio stream, meaning that everything is a part of the same mechanism, the same entity. We don't perceive this duality between control and synthesis, which is, one of the curses of digital musical instrument design.
Okay, I understand. So can you maybe share a little bit, the process behind creation? Because I imagine it was very challenging, but also very interesting.
Absolutely, yes. So as I said, it was a necessity. We needed to come up with a new technology so that people could manipulate how the electronics of the digital musical instrument works with an immediate outcome and also with a very strong robustness so that you don't break anything. This is another feature of Bela. It's a product, right? Which means that it went through several testing stages and it's very difficult to get no sound once you have your application running, unless you make a big mess in terms of programming. But other than that, it's incredibly stable. And so we started by focusing on some embedded Linux boards that were available at the time in 2013. And we landed on the BeagleBone Black, which is completely open source and open hardware and allows for a lot of customizability, difficult word. And specifically, we designed some hardware that extends the capabilities of the BeagleBone Black, leveraging this openness, and also deployed some firmware that is really geared towards real-time audio and its development. So the idea was basically to use something that existed already, not to reinvent a wheel, but leverage the openness and the features of such a system to turn it into something that was designed specifically for audio development and audio interaction. And this entailed working with a specific version of Linux. So specifically, we're combining two kernels, a real-time kernel using Xenomai for people who are more into this, like fetishisms, and also focusing on how to interface the real-time kernel with the sensor reading mechanisms, these custom chips, and also the audio codec, so that everything can run as fast as possible and as stable as possible. It was the first time for me to work on embedded audio because I came from virtual reality, HCI, but I had a strong background in computer engineering, but not in audio. So basically, this was coming back to my roots, coming back to closer to the hardware layer of things, and it was very exciting. It was very challenging in the beginning. I remember the first 2 weeks when I was working there. They were tough. Yeah, I felt I could not accomplish anything for 2 weeks, which was very stressing, very stressful. But then everything clicked, and also thanks to Andrew, a fantastic mentor and supervisor, and also the people around me. I felt I was surrounded by people that were way smarter than me in general and were more knowledgeable in terms of audio than me. I was able to bet on my skills, but also be a sponge and learn as much as possible from that.
Yeah, that's maybe worth asking here. You mentioned this a little bit, but in a broader sense, like this, your whole time at Queen Mary's, what was your kind of experience working there? Because it's one of the largest, I think, if not now the largest research facilities for audio in the world.
Yes, I was not fully aware of that at the time. So I came there because of the musical instrument bait, right? I was really into musical instruments, digital musical instruments, either virtual or physical, right? And so I kind of overlooked this. But then it became apparent. It became apparent because of the quality of the research that was carried out around me, and also the the character of the people that were hired, both as PhD students and as researchers or faculty and stuff. So yes, it was a life-changing experience for sure. And I still have connections, of course, with the Center for Digital Music. Right now, I'm collaborating with a PhD student, incredibly smart, who would have known. And what else? Beyond that, I think that C4DM and QMUL also gains a lot from London itself. Like music scene, the art scene in London is incredibly strong, as everyone knows. So QMUL is really rooted into it. Even when I was working there, we collaborated with a lot of artists that decided to participate in our user studies because they were really interested into new ways of making music, which is something that you don't find at that scale, at least in many other cities in the world.
Mm-hmm. Cool. So coming back to the Bela platform, what were specifically your areas of responsibility there?
Sure. Again, we didn't know Bela was a thing. I just started developing something. I started developing a C++ audio engine. Most of it is still part of Bela. A big part of it, I would say, has been reworked, of course, but the main structure is there. And I worked a lot also on testing all the hardware interfacing. So as I said, we had some chips, integrated circuits that we were using to sample sensors, but also output audio. And these were based on I2S, SPI, these very basic protocols. So I really took a deep dive into the Big Open Black and to try to understand how to integrate these protocols and our C++ core code. And many of these chips, some of these chips, they are not part of the final design. So there was a lot of course, exploration. And then I started developing two musical instruments as a first test bench, right, for this technology. And then we realized how strong it was and how it could have been turned into an actual product. I was not part of that thought process at that time when actually things sailed towards the product direction. I was not part of the team anymore. I moved along with my career. But I was always in contact with the Augmented Instruments Lab, which is the lab that Andrew supervises, and basically they created all the product side of things on their own.
Okay, I know that you touched on this a little bit already, but do you remember any specific skills that were especially challenging to master, or that you found particularly useful in your later career that you needed to learn while working on Bela?
Absolutely, yes. So it was my first embedded audio programming experience. Audio, yes. Programming, absolutely, in the past, but embedded audio programming, not really. Especially we were working on a Linux board. And I was a Mac user at the time. So most of my development was between Mac and Windows, because virtual reality, even at the time, was more common on Windows. So I didn't have much experience on Linux, and it became my passion at that point. I never went back. So it was kind of the zombie bite, right? So once you get bitten by Linux, it's difficult to go back. And understanding, of course, open source was a big revelation to me. And maybe people say, oh, duh. Wow. In terms of research, it really changed my mind. Not mind, but the way I operate until today. And then all this idea of having full access and control over the operating system, and using packages that have been developed by other people, or maybe even contributing sometimes even with just some comments or requests to this larger community. It was a fantastic experience. And beyond that, really delving in low-level audio, like popping samples in and out of buffers and working with the very low memory locations that are shared with the audio driver. That was pretty cool. That was something that, again, I think I discovered what I really liked beyond being an electrical engineer or a computer engineer and working with computer science and HCI, virtual reality. Everything was fun, amazing, but this thing was the thing that I really wanted to continue working on for the rest of my career.
Awesome. And I'm really impressed because from what I heard, from also what I see, like I think in audio it doesn't get more difficult than ALSA on Linux. So
I was not aware of that. Actually, this is funny. Yesterday, when I was going back home, I was thinking of a possible class because I was working on some audio stuff, of course, low level. And so I was going back home. I was thinking, hey, it would be cool to create a class or propose a class in the next years when I have a little bit more time that is really about writing an audio engine from scratch, from low level to high level. And of course, I said, why? I should use Linux because it's so clear to me how it works. It's so pristine, right? But apparently, it's more difficult than what I thought. So thanks for the feedback. Honestly, I don't have much experience on other systems, so I'm pretty biased, right? So probably I went through the hard way without realizing it.
Yeah, I like it seems to me this way exactly. So like okay. you went exactly the hard way, but now I guess like all the other APIs are only simpler. But yeah, this is of course just anecdata, right? This is anecdotal, so everyone's mileage may vary. Yeah, absolutely.
Yeah, I don't think I'm smarter than the average audio programmer. So that was definitely a random decision.
Okay. So is the Bela platform used commercially nowadays still?
Yes. Yeah. So Bela was designed originally as a research platform. Then it became a commercial platform, I would say initially for DIY development, not just to carry out research and user studies. But also for people just to expand on their creativity, making music, making interactive sonic installations, anything that revolves around the use of technology and sound. But nowadays it's also used a lot in teaching. I teach using Bela, of course, and I see many other universities and I see other professors that are created some classes that gravitate around the use of Bela. And I understand why, because it's super straightforward and it's very well crafted. Sometimes I see that it drifted towards a direction that is less, say, hardcore in terms of development and more suited for teaching or DIY approaches. It's very different the way I use Bela nowadays compared to how I was using Bela or whatever system it was before when I was at Queen Mary. I was, hooking up my own IDE with my own remote debugger. I was very, I don't want to say picky, but I needed an environment that I could trust, that I liked, whose workflow was really in tune with how I like to work. And nowadays is more kind of use this web API, web IDE. It's easier, it's faster. Yes, you can also use your own IDE, but it's more complicated. And there are so many tools. Look at this, how many amazing tools. You have a built-in scope, you have a graphical user interface. Why would you go the other way, right? So I had that kind of feeling that it's really created to make this entry fee very, very low.
Okay. I'm curious, just maybe if you were not involved with this, we can skip this question. But could you maybe say what are the steps necessary to just set up quickly the Bela platform? So I just need to purchase the hardware, right? Yes. And then I need to download the firmware, install it on the hardware, and then I can launch it and hook into the web IDE where I can change the program and then let it compile on the board and then let it run. And it's now my musical instrument / effect.
Exactly. So the idea, there are of course different options, but you can buy your own Hackable Black if you want and just order this Bela Cape, the hardware extension, and download the firmware, which is completely free. The firmware is open source and even the hardware is open hardware. So potentially you can create your own version. And then, yes, you hook it up to your computer. You can log into a specific IP address because Bela works as a network interface too, or the Hackable Black, I would say. And at that point, you are presented with this IDE. You have it's a framework, so you have some skeletons for building your own projects. And there are some examples that show you how to interface with sensors, whatever you hook up to the board physically. And then you build on the board itself. There is a compiler that does not cross compilation. You are not using a tool chain. You use the actual built-in compiler. And eventually you can set up the board to launch your application at startup so that you don't have to be connected to your computer. You can use a battery pack or whatever you want, even connect speakers so that it can become a self-contained musical instrument.
Okay, cool. And do you also have some ready-made building blocks in terms of software like filters or generators?
Yes, absolutely. There's a variety of libraries, starting from filters. But by the way, filters make use of the specific hardware accelerators that are available on Bela, which are kind of difficult to program for. This was one of the challenges when we designed our instruments. So we were combining C++ and assembly, and specifically we were working on the neon parallel floating point unit to make sure that we could crunch more samples without running out of CPU power, basically. And many of these features are now included in the libraries. So when you just declare an object, like a filter object, the implementation is very optimized. And it's not just C++, by the way. You can use Bela with C-Sound, pure data through libpd. I think Faust now is supported. And in most cases, the code that is already there, part of the framework and the libraries, they leverage these specific hardware features, and they're very optimized.
Okay, nice. And have you ever compared Bela to other audio-specific embedded platforms? I'm not, an embedded expert, but names like I think Daisy, DSP crossed my ears. So have you ever tried to compare these, or maybe what makes Bela stand out in this environment?
I didn't do that. Other people did, even in papers. So we have some papers that compare different metrics of Bela and other platforms. I would say that in terms of CPU power and responsiveness, Bela is still state of the art nowadays. For example, Daisy Seed is very responsive too. It has a lot of features, including sensor, we call it analog inputs to read from sensors at a very high rate. But it's still a lower specs compared to the Bigelow Black. And also comparing to these extra features beyond the CPU that the Bigelow Black. For example, the Bigelow Black has 2 programmable real-time units. So you can really go bonkers if you want. You can really get very high performance out of the Bigelow Blacks, even if it's just a 1 gigahertz CPU. So not comparable, not even to a Raspberry Pi. Speaking of which, you can go to a higher spec board, but it's difficult to find an audio environment that is so well crafted as the one that we find on Bela.
Sure.
Yeah. And this speaks a lot about it. You can experience the difference in terms of not just the ease of development and deployment, but also the actual performance in terms of responsiveness, jitter, latency, all this kind of stuff. It's very difficult to accommodate on the Raspberry Pi. What is that, number 5 now we have, which is very powerful, probably quad core, something like that. But still, it's difficult to make a musical instrument that really feels as responsive as one that is made with Bela.
Okay, thank you. I have one last question on Bela.
Absolutely.
I think it's like a super interesting topic. So I'm personally a huge fan of Bela tutorials on YouTube because they not only teach you Bela, of course, but also a lot of very useful concepts of audio programming that I think you cannot even get anywhere else. So I just wanted to ask, were you somehow involved in making these tutorials?
I like your question and how you framed it. In fact, they are called a real-time DSP with Bela, right? So the point was really about real-time DSP. I was not involved directly, but yes, indirectly, in the sense that course, online course, series of lectures, come from a class that I was TAing for when I joined Queen Mary. Nice. So Andrew was creating for the first time the class. It was the first time he was teaching the class when I was there. And we started thinking about what we could get from the research and bringing it to class together, and how things panned out in class, things that were, students understood easily, or things that were a little bit too challenging. So we kind of reworked a little bit together. I was, let's say, a TA advisor. I was just advising, giving some feedback. So the actual The idea, everything was dealt by Andrew. So absolutely, all recognition should go to him. But I'm happy that I was part of that. And in fact, nowadays, I teach a class that is very similar, and I leverage both sides of the experience, not just what's online already, but also what I remember from 2013, 2014.
Awesome. So anyone listening to this podcast, please, if you haven't seen them already, go to YouTube and find the tutorials on Bela by Andrew McPherson. I will definitely list to them in the episode notes, but they're really amazing and very well structured. And they're completely free, of course, because they're on YouTube. Okay.
And also, let me say that you don't have to have Bela. You can use JUCE, right? Right. And you can, I mean, many of the things that are shared in those lectures are transferable to any audio environment. Of course, when you're talking about reading from sensors, no, you need some hardware that is dedicated. But other than that, for what concerns DSP, real-time DSP, there's a lot to learn there, no matter what.
Yeah, I definitely agree. Okay, in 2015, you also co-created the D-Box, which is an example of a hackable musical instrument. Can you share what was it and what was the idea behind it?
Yes, actually, it was 2014 when we designed that instrument, and it's basically the final outcome of the Hackable Instruments project. Mm-hmm. It's a hybrid digital and analog musical instrument that on its own has very few affordances. It has 2 touch strips and can only play a note that can glide, and there is a little filter on top. But if you crack open the box, you see that there's these mumbo jumbo wires, and with discrete components like capacitors, resistors, and whatsoever knobs. And you can actually rewire it on the fly, which doesn't mean that you're changing just the analog behavior of the system, but you're also changing the digital behavior. Whatever is hard-coded in code, indeed, and runs on the board is affected by the currents, the voltages, actually, that are outputted and inputted to and from this little breadboard that is attached to it. So the idea is that, okay, you want to prepare a piano, you can. Now you can also prepare, if you want, a digital musical instrument by means of hacking and modifying how the circuitry works. And the cool thing was that we were interested into understanding whether or not this kind of possibility or opportunity to appropriation, just to go back to what we discussed earlier, was related to knowledge. Do people have to know how this matrix of connections work to actually appropriate a modified instrument in meaningful ways? Or maybe this is not necessary, right? Maybe serendipity and exploration is strong enough as a driver. And in fact, that's exactly what happened. We saw different approaches, very different approaches, with and without knowledge, but not a limitation on the appropriation of an instrument, which is kind of in line with what we see with acoustic musical instruments, for example. You don't have to know to nail the basics of acoustics, or like the equations, the scientific understanding of the instrument. This kind of knowledge is embedded in the instrument, but maybe you just don't get it, and it's not important. You have your own mental model that is flexible, and even errors in your own mental model may allow you to appropriate the instrument or approach it in completely different ways. So it was very exciting, and we advocated for this kind of design approach at the end of this project. We tried to share the advantages of putting that extra effort in the design process so that things can be modified by the user, so the musician, the performer, whatsoever. But it's very complicated. You need to have technologies that allow you to do so, much like Bela, for example. And even myself, I'm struggling to follow the same logic or rationale when using different technologies, because, not everything can run on Bela. We can discuss this later, but there are some limitations to what you can do on Bela. And there are many other technologies that are very appealing from a musical standpoint. And unfortunately, it's still very difficult to provide that kind of freedom and hackability, in a sense, to all the technologies that are available nowadays.
Okay, cool. Thanks. And is the D-Box still used today, or did it kind of end up in this, let's say, prototype phase or example phase?
Definitely an instrument that is rough around the edges, but it was shared with many musicians around the world. And I guess it's probably from time to time, people are still using them. A friend of mine actually gifted one, when was this? 2 years ago. It still makes music. Sometimes it samples the instrument, or maybe just, as a music in system, just to make some sounds to entertain himself. So I assume that, much like my friend, other people that received the D-Box for during our research experiment, which, by the way, gave out as a gift the instrument at the end of the user study, many of these people probably are still making music from time to time with it. But it's not a product. It's really important to emphasize that.
Yeah, sure. Okay. So you did a lot of stuff at QMUL, but what did you do afterwards?
Afterwards, again, I changed, of course. I changed because the important thing was the role, not the topic, right? So I won a Marie Curie fellowship, which is there are some funding that are available from the European Union to support research across different countries, both within the EU and between the EU and third countries like Canada, the United States, but also Asia. And I ended up getting this fellowship between Italy and Canada. Specifically, I spent 2 years at the University of British Columbia in Vancouver, Canada. And I work with audio, of course, and music, but from a different standpoint. I started working on physical modeling, and specifically, I joined a lab that has a track record in vocal synthesis in general. I would say articulatory vocal modeling. So they simulate how the different articulators in the upper human vocal tract works to generate sound. And they run, of course, also digital simulations, sometimes simplified, sometimes extremely precise, to either understand how these acoustics work or to generate sounds digitally. And I work specifically on models for the generation of sound. And the interesting thing is that this is a completely different problem. It's really about advice at the time was really about the limitations in terms of CPU power that made a real-time implementation of some of these algorithms kind of impossible at the time. I don't want to say impossible, but limited freedom of implementation. And so we switched to GPU accelerated synthesis for these physical models. And so on one side, I continued working on this more health-oriented pathway with them. So sound, yes, but applied to the generation of voice or understanding the problems of voice generation, the utterances. Well, if a system is not working, the output is different. So maybe by understanding the output, we can go back and understand what is mechanically wrong in it. But on the other side, and on the other end, I continue working on artistic applications of these technological goals or milestones. And in fact, I came out with a version of this model, physical model that we were using, that was really geared towards making music rather than generating voice. And this is basically the core of an instrument that is called the Hyper Drumhead. It's really about simulations. In the name, you hear the part of the name that says drumhead. So we are simulating in this instrument a drumhead using physical modeling. So a kind of precise simulation of what happens when we hit a drum and some waves start propagating in 2 dimensions. But the idea is that we make it hyper. So that is not just a simulation of an instrument that exists already, but we can tweak the physics, which is something you can't do in reality, to turn this instrument into a different instrument, to make sounds that are not possible to make. And this instrument is pretty exciting, in my opinion. I think is the most interesting instrument that I designed so far, due to the possible applications. Is not tied to a research question about how we make music, but it's tied to how the research question that is asking what different music can be done, right? Is there a type of music, a type of sounds that are more difficult to make even with computers nowadays? How can we go beyond that? How can we go beyond that barrier and make those sounds more achievable to everyone, let's say?
Mm-hmm.
And it's still I would say, not a product. It's still an instrument, even if I designed it many years ago at this point. What was that, 2017, 2016? It's not at a stage of development that can be considered a product. But I keep working on it. I keep working on the core mechanism. I keep adding features, even sometimes isolating features that I like. And it's still a very living part of my research trajectory and artistic trajectory.
Okay, cool. So I saw the demonstrations of the instrument on YouTube, and we'll definitely also link to them in the episode notes. But can you maybe, I mean, I know maybe this goes against, the design of digital music instruments, but can you maybe describe what is the approach that you take when you create music with this instrument? So not, a manual, but your personal approach to using this instrument and making music with it.
Yes, it's actually a very good question, because this is an instrument that, in my opinion, puts you in front of a different system, a different paradigm. So let me explain a little bit better what it does. So you have this flat surface. It's actually a retro-projected screen. It's a table, basically, a large table screen, touch screen. And you can inject sound sources into the screen, and these waves propagate in 2 dimensions. And then you can draw boundaries around the sources, basically creating some resonances, as if you're drawing the shape of the 2-dimensional object where these waves are propagating. So imagine that you have a drumhead, but you can start cutting a portion out of it, and you excite it, and then you put another excitation on another side. Maybe you stretch it, maybe you make it smaller. So really manipulating the physics of the instrument. But then there are 2 other possibilities. One is to physically modify the material properties of this object. So changing, for example, the density of the material or the speed of the propagating wave. So as if you're switching materials, which is, again, something interesting. And the other thing that is pretty different than many other instruments that we use nowadays, at least the digital musical instruments, is that it's really visual based, because the propagation of these waves is not just sonic, but also it's also visual. You see these waves, of course, these oscillate very fast, so you see a downsampling of these waves, but using color, it gives you a direct feedback on where there is more sound as opposed to where there is less sound, where there is more high frequencies and when there is more low frequencies and stuff like that. So you can actually manipulate the system guided by both the audio feedback, the sound feedback, and the visual feedback to create very interesting soundscapes. It's really an instrument about soundscapes. It's not about notes, pitches. It's really about timbre, evolving timbres, using your hands, your fingers to actually drive these resonances, much like you ride a no-input mixer, right? You listen, you modify. In this case, you listen, you modify with your hands, but you also look at what's going on. And it's very big. So you can also see different things happening on different sides of the instrument and use different virtual microphones to sample different parts and move them around and follow in this cloud of sound, right, as it evolves over time. So the idea here is to really look at the instrument and be open to its kind of agency that you can see from it, just transpiring from it. And then go on it, like ride it and fight it sometimes, or sometimes concede it.
Okay, awesome. I mean, the demos are super impressive, and I think my favorite part was when I think it was you drew, a flute, so a resonator on the screen, and the sound actually stopped being, drum-like, noise-like, but started to be pitched, right? Because that's what resonators do. This was really amazing, and it shows, I think, the full power of, combining this kind of visual drawing with physical modeling. What I was curious is that if you had, an experienced drummer playing this, maybe you are an experienced drummer already, that I don't know, but I imagine that, a drummer would be really keen to use sticks, to maybe divide, the surface into various areas. But then, correct me if I'm wrong, but I think drummers feel most comfortable with sticks, so they could, drum super fast into various areas. And I was curious if that's something that you ever, considered in this kind of experience.
That's a good question. And the answer is, this is not a drum. Even if the name suggests that it comes from a drum, as I said, this is more of a timbral instrument. I don't recommend anyone to play this as a drum. I did it, of course. I actually performed, what was this, in 2018 at the Gotham Musical Instrument Competition. And the first part of my performance was a kind of a drum style performance that then drifted into timbre, because I wanted to showcase all the features of this instrument, the weaker ones, but also the stronger ones. Now, beyond this was a showcase, of course. I wanted to really brag about what I did, right? But from a musical standpoint, I think that you're not supposed to use a system like this in place of a drum set. Again, there's a problem with responsiveness in digital musical instruments, and this system that uses an actual GPU, so not Bela, not an embedded system, uses a laptop with a beefy GPU. Well, in that case, latency is there. It's perceivable. No matter what you can do to optimize it, you still have some limitations that would make this something like a lesser experience compared to an actual drum. Why would you do that, right? What you can do is to go beyond the limits of a drum set and use it to make different sounds, different gestures, even if the underlying logic, the underlying math is the same as the one that describes how a drum works.
Okay, that is a very good explanation of this idea. So can you share maybe some technical details about the implementation of the hybrid drumhead? So I'm especially interested in what kind of approach, what kind of numerical method did you use for solving the physics of the 2D space?
Sure. It's pretty straightforward from a theoretical perspective. It's a two-dimensional finite difference time domain solver. The tricky part was to design an ad hoc stencil that could leverage how OpenGL works. So we used OpenGL to basically solve most of these grid points, which means solve basically the locations within this large surface in parallel. We have hundreds of thousands of these points, right? So if it is possible to run them in parallel because they don't depend on each other, we should do that, right? It's to cite a very famous paper, audio sometimes is embarrassingly parallelizable. So we should strive to do that, right? So the idea was to use OpenGL to get a visual as well as a sonic output at the same time. I didn't come up with this idea. One of my coworkers was working on a system like this. And so we just decided to work together on an actual instrument that was challenging, let's say, some, as I said earlier, some musical interaction paradigms to make music. And so we created this stencil that solves everything in parallel. It was very difficult. It was like really fitting how OpenGL works. And specifically, we leveraged some, at the time, new features that allowed us to read and write from textures at the same time, which is not a given. There are many drivers that don't allow us to do so, even nowadays. So very specific, very carefully crafted, but eventually successful. It was a lot of fun.
Okay, cool. And my question on exactly the GPU and OpenGL is that in audio plugins and audio applications, and probably also on embedded hardware, is that you work in this paradigm that audio is single-threaded, that audio runs on a single thread. And there are a few attempts to move audio processing of audio plugins and applications to the GPU. I think notably the most well-known company that's trying to do this is GPU Audio. This is not a paid sponsorship. I just wanted to be fair. So the main issue everyone says is that the problem is not that GPU processing is slow because it's very fast. The problem is the communication between the CPU, so the audio thread, and the GPU. So I was curious, how did you manage to solve it in the case of your instrument?
Sure. Yeah, it's exactly that. The bottleneck is the throughput, so the bandwidth, basically, of the communication. The solution for us was pretty straightforward, just by using buffering, right? So instead of computing or retrieving sample by sample from the GPU, we just retrieve a number of samples in a buffer that is exactly the same buffer that then is shipped to the audio interface. It's important to notice something, though. The system we were working on had a very large visualized simulation, right? A lot of points in this domain. But we were only sampling some of them that were turned into an audio stream. So only those samples were going through the bandwidth problem, the bottleneck. So that was how we basically worked around. I had basically now a version that is multi-channel, so I can actually sample anywhere and in the simulation and get separate streams of audio, which of course makes for a more challenging bandwidth situation, but it can still run in real time. So as long as you don't want to move the whole output of your simulation from the GPU to the CPU, then you should be good. What is the problem? The problem is that you maybe cannot afford the small buffers that people like, the sweet buffers of 32, 16 samples, right? You need to work with 128 to 256. Sometimes it's okay if you don't need very high responsiveness. Sometimes it's a big problem. So the other option that you have is to ditch the GPU and use other type of parallel computation options. For example, SIMD is used sometimes, or even the neon is used as much. We use it on Bela too, right? And maybe you have a smaller scale, but you can still parallelize. And if you have, a big enough algorithm to crunch, then you may see a benefit. And in that case, the memory is shared, so there's no problem. There's also another comment. We see on some machines, some architectures, a unified memory architecture, which should basically fix the problem, right? Apple machines do that. The Steam Deck does that too, right? It has a unified, if I remember correctly, a unified memory architecture. So if this becomes the standard, then maybe GPU accelerated audio can become the actual standard in audio. Who knows, right? Even if probably now deep learning is on the rise, and it's probably, I would bet on that rather than on GPUs. Ideally, we should see both deep learning on GPUs and then back to CPUs, but we'll see.
Okay. And final question on the Hyper Drumhead. Are there any plans for commercializing it, or will it stay like your personal instrument?
So, not commercialized so far because, as I said, it's really custom. Its implementation is custom. It leverages some specific technologies and needs GPUs that are not available everywhere. So I was not able to actually share it, not just as a product, but in general, share it as a project that can be easily replicated beyond some software implementations. However, I have been working on a similar version of the same system that it does not simulate, but emulates using deep learning, speaking of which. And I have something, good preliminary results right now. I have a kind of a version of the Hyper Drumhead that works on my phone right now. It's not exactly the same, but we're getting there. And this is part of a collaboration with another researcher. So not necessarily, again, my merit, but working together on this. So if everything goes fine, maybe we could turn it into something that is more easily accessible. Maybe a product, but for sure something that is more easy to replicate, let's say.
Okay, cool. So there is a chance of getting the Hyper Drumhead on our Android devices then.
There is a chance for sure. By the way, everything is open source. So if anyone wants to take it and do their own implementation, it's fine.
Cool. So after you left Vancouver where did you go afterward?
So I would like to say I went to Boston, to Northeastern University. But no, actually, it took me a year to find a job. Switching from a postdoc to an actually faculty position, especially one that you like, it really is in line with your interests, is complicated. And so I want to share this part of my experience. It's not always success. There are some situations in which it's difficult stuff. It took me a year. But then I managed to find this position at Northeastern University, assistant professor in music technology, which is what I wanted to become. And I'm still here. This is my last year of tenure track. We'll see how things go. I'm pretty excited about everything that happened in the last 5 years in terms of my role, the development of my role, more responsibilities, more also rewards in terms of connections with students, which is what I really wanted to go for. So satisfied, definitely.
Okay. So let's maybe discuss what you have done in these 5 years, and please feel free to add what I missed in my preparation for the podcast. But what, of course, I think interests me the most is that in the last 2 years you have published work on the LDSP C++ framework that allows low-level audio device control on rooted Android devices. So can you summarize what was the motivation for this framework, and what are the limitations of the Android audio ecosystem that inspired you to create it?
Sure, I have to be careful here because you know a lot about this stuff. The idea for this project came from a 2022 talk at the International Conference for New Interfaces for Musical Expression. Sorry, said it wrong. So, International Conference on New Interfaces for Musical Expression, 2022. There was this presentation titled Circuit Bending and Environmental Sustainability by a researcher that I know. And I was very inspired by it. It was really focusing on discarded electronic devices and how they can be recontextualized as new pieces of music technology. These are the words that I use, new pieces of music technology. And they were not talking about phones. They were focusing on anything that can be circuit bent, basically. But it clicked. The image that I had in my mind, this mental imagery, was all these piles of discarded Android phones. We all have one tucked in a drawer, and we can find so many at flea markets. I thought, these are powerful devices, right? Probably the specs are similar to a Big O Boom Black, right? Maybe not as powerful as Bela and all its, gadgets, but whatever. And so I started doing some research, and I realized that yes, Android specifically is kind of a branch of Linux, so it could be kind of easy. I was delusional. Kind of easy to turn it into an embedded audio board, right? Even if it's not a phone anymore because it doesn't have WhatsApp, because it doesn't update it anymore, or maybe it has a broken screen or the battery doesn't last long enough. Maybe you can just hook it up to a computer and drop a binary and use it to make music, right? To process sound, whatever. And that was the incipit, basically. And then this was a rabbit hole. I quickly realized that this was possible only on the Android side, or easily done on the Android side, because iPhone and iOS is more of a locked ecosystem. Probably it's possible, but there's also some stuff related to legal liability and stuff like that. So I'm a Linux guy, so Android spoke to me in a sense. And eventually, I spent a lot of time trying to understand or kind of reverse engineer how audio is handled by audio apps. And I realized that it's actually pretty complicated. And that's why when you develop an audio application, you have to jump through so many hoops compared to deploying on a Linux embedded board. But I could see the potential to do the same, to apply the same workflow that we use on an embedded board. And so I designed this. It's actually an environment rather than just a framework. The framework is part of this environment. There's an environment that is really designed to help you hack the phone, kind of reverse engineer and set some parameters that are necessary for your phone to work. And then you can use this framework to write your own code. It's basically a big C++ low-level audio engine. And with some examples, it's very much inspired to Bela. So there are so many examples and libraries that you can use. So you can start from some templates, write your own code, and then you can use the environment to deploy it and run it on the phone. You can also test it. I just finished the first version of the debugger, so I can also debug it now, which is a good thing. And eventually, there is also a variety, an ecosystem of features like a graphical user interface that allows you to use the environment to either interface with the application, but also maybe test it and debug it in a different way, not just code-wise, but also interaction-wise. So it's really a big package that is designed to give a different experience to people that want to make audio on Android phones. And specifically, this framework is based on the Tiny Elsa library, which is the library that interfaces on every Android phone, basically nowadays with the kernel level Elsa driver. So it basically connects to the very last layer of the environment framework, of the Android framework, basically.
Okay. So you mentioned that also your framework ships with a GUI possibility, but is it kind of like an alternative to the one proposed by the Android people?
Yes, yeah. This one that I have is kind of as I said, testing mechanism on debugging mechanism. So it's a web GUI. If your phone is connected to the same local network as your computer, you can actually access the GUI from your computer, or you can access the GUI from a browser running locally on your phone. So the idea is to create some quick sliders or very basic interfaces, or maybe not so basic. For example, the version of the Hyper Drumhead that I have, it uses a fairly developed GUI to interface with the instrument. Still a prototype, though, right? There is a way to embed LDSP binaries in actual applications. You still need to have your phone rooted, but at that point, you can turn your C++ code into the native code, C++ native code that you include in a regular Android application. Mm-hmm. So you have access to all the features, the higher responsiveness also, because that's what it does basically. LDSP allows allows for higher responsiveness, and also removes some strain on the CPU, because of course it runs at a lower level. And you can kind of leverage these benefits even if you embed your C++ code as part of an actual Android application with the Kotlin-based GUI or whatever you want to use.
Okay, so the main benefit, as I understand, is that by bypassing a lot of layers in the Android ecosystem, you're allowed to obtain a lower latency, basically.
Rather than lower latency, which is true, I think that you're using the CPU only for basically your audio thread or sensor threads.
Okay.
Nothing else related to your application is taking up time and power on your CPU, which makes everything simpler. The whole architecture of this application, it's not an application. You can just run a binary. You can just deploy a binary and run it on a shell. It makes it so simple, so you can really focus on the audio side of things if that's what you're interested in. If you're interested into an app, designing an app is totally fine. There's nothing wrong with it. But if you're just interested into deploying some audio applications, interactive audio applications, binaries at a low level on a phone, you don't have to go through all these many hoops from the top to the bottom to get there.
Okay.
And of course, there is an advantage that is measurable. A couple of years ago, we were on a study comparing the number of oscillators that can be run in real time in parallel on phones. So the same code running at low level, at high level, so at LDSP and an app. And in many situations, there was a staggering advantage, like
even 200% advantage sometimes in running at low level. Not in all the configurations, though, of course. Depends on the buffer size and also on the phone. And that's what that was my first driver. Like, how can I use the CPU to do just what I want rather than focusing specifically on latency? Also because there are many latency bottlenecks in Android phones that may depend on the actual codec that is being used or the mixer that is implemented in the system on chip. So those hardware limits cannot be really overcome. But the software ones, yes, LDSP is really about that, hacking the software side of things or the firmware side of things to work as low level as possible.
Okay, awesome. And of course, like the other main benefit is then fighting against this e-waste of Android devices, which I'm a huge fan of personally. And especially because I was really disappointed, I think it was 2 years ago, when I discovered, or I received, some quite old, Android tablet, I think, but I haven't found a way, to root it, even just to make something useful with it. So I'm curious, is there, a surefire way to root every Android device if you're persistent enough?
Well, at this point, after some years of research, I'm sad to say no. The problem actually is the locked bootloader, which is a decision made by the vendor, which is very sad. So ideally, you can root Android, but these newish phones, they have a locked bootloader, so not anymore. It's not possible anymore to have the same approach for every phone. And sometimes some phones cannot be rooted. But I would say there are some movements like right to repair, or slogans like, if you pay for it, you own it. I think those are steps into the right direction, because if I buy something, a piece of hardware with some firmware, I should be allowed to load on it any firmware that I want or tinker with it. I'm not going against any terms of use that may fire back or be detrimental to the company that designed and sold this device. As a individual, right? I can, much like I can install on my ThinkPad Linux or Windows, I should be able to do the same with an Android phone. So we'll see what happens. I'm hopeful, but complicated.
Okay, cool. So I think it's a interesting factor to look into when picking, your next Android device then.
Absolutely. And nowadays, what I do is to check the page of Lineage OS, which is a custom ROM. And these people who are fantastic, they designed a specific version of Lineage OS for a phone only if the phone can be rooted. So if it's there in the web page, it means that the phone can be rooted.
Nice. Okay, so now I wanted to move from talking about the research that you were involved in more to the teaching that also is a large part of your career. So maybe first question is, what are you currently teaching?
Yes, definitely teaching is a very good part of my career here at Northeastern. I spent a lot of time becoming a better teacher for sure, and I really like it. Right now, I teach in 3 classes, and mainly three classes in rotation. One is Introduction to Music Technology, which is we call it a 1000 level class here, which means that people that don't have previous exposure to music technology should take as a first step into the subject matter. And it's really about sound, acoustics, psychoacoustics, electronics, analog audio, digital audio, sound editing, sound design, the digital audio workstations, mixing, production, performance, everything surface level. So laying the foundation to truly become eventually an audio researcher, if you want. So knowing exactly how things work, know how things work, and then understanding where there is space for a deeper analysis and deeper dive into the topic. Then I teach electronics for music. which is one of the so-called electives here, which means you need to go through Intro to Music Technology and another intermediate class before getting there. And that is really about analog electronics to design oscillators, filters, amplifiers, distortions, and stuff like that. It's very basic because it also includes an introduction to electronics for people that don't have any exposure to electronics. But I also have students that come from ECE, and so they are, of course, faster at grasping the basics of these circuits, and we can have deeper conversations and more challenging conversations about signal flows and stuff like that, also designs. I think this is the class that I like the most right now. I think it's the most original one. I would have enjoyed so much a class like that when I was an undergraduate. Especially as an introduction to electronics, it would have been so sexy. But I went through a more common route, like the traditional route.
Yeah, me too, unfortunately. Yeah.
yeah, exactly. That's what I'm saying, right? It's very uncommon. Then here, and I have to say, shout out to Northeastern, because they really allow me to work or be part of the curriculum in the way I prefer. Mm-hmm. I have very few impositions or constraints. Then I teach embedded audio programming, which is another upper elective that is my version of the real-time DSP with Bela course that I TA'd for, and then Andrew is teaching, or used to teach. I'm not sure if he's still teaching it. Anyway, it's crafted to our student population, keeping in mind that we have both music majors and combined majors. So people that may have had previous exposure to programming and physical computing, and people that maybe didn't. And then there are a couple of other classes that I teach from time to time. These are not my favorite classes. These are, one is called Computer Music Fundamentals. That is really about learning audio DSP, but at high level. So we use Max, Cycling 74. And so we design oscillators, sample players, filters, granular synthesis. We implement ring modulation, FM, AM synthesis, all this kind of basic stuff, but at least in blocks rather than writing the code on your own. So it's intermediate between what you do in a DAW, what you use in a DAW, using plugins, and what you do in embedded audio programming when you actually write the code. So it's a good intermediate step. I'm not an intermediate step guy, though, either fundamentals or more hardcore stuff. So that's why I typically don't teach this class. There are other professors that are, very strong in using Max, and they are very strong in DSP too. So I'm happy to leave this class to them. And the other class that I teach from time to time is acoustics and psychoacoustics of music, which is basically it expands upon the first unit of Introduction to Music Technology, where we actually discuss acoustics and psychoacoustics. And it's a very nice class. It's very science-oriented. We talk about measurements, but we also talk about how musical instruments actually work from both a mechanical and an acoustic perspective. And also, there's a lot of brain involved in a sense, so how the brain works, and psychology of listening to sound, and physiology, of course. I don't teach this very often because there are other professors that have very strong backgrounds in acoustics and psychoacoustics and mathematics too. So when it's, there's a spot that is needed to be covered, I teach this class. And that's all for now. I plan to propose, as I said, a couple of maybe more advanced classes in the next years, specifically one on digital musical instrument design, actually called New Interfaces for Musical Expression, to be a little bit more wider. And then I would like to propose a graduate class that focuses on the design and development of an audio engine from scratch.
Okay, nice. I think these are super interesting, and there are so many people who would like to take these courses. But yeah, that might be the subject of one of my next questions. But I wanted to ask you, because you said, which I think is very on the spot, that you also were working on developing your teaching skills. And I know, as a fellow teacher, I'm also interested, in other people's methods to teach these subjects. And from the subjects that you mentioned, I think especially important are, introduction to audio programming, or introduction to music technology, and embedded audio programming. So could you share your philosophy on teaching students this subject?
Yes, yeah. I really focus on the basics. So I'm talking about shaping a college career, right? So a person that enters college, which is different than a person that may want to learn on their own for personal interest or to pursue a career that is not driven by college. Every option to learn is amazing. Every reason to learn is amazing. I'm just focusing on the demand here, right? We are at a university, a private one. So the demand is this, and I'm, paid to respond to the demand. And here I think that basics is fundamental. Students need to first understand what sound is, what audio is, right? What DSP is, yes, but before, if you don't know what digital audio is, you cannot understand DSP at all. There are so many tricky parts that you may have an intuition about or an intuitive understanding, but eventually it gets so technical that what makes a difference is the mastering of the basic knowledge, the fundamental knowledge. And beyond that, I also emphasize a lot the description of how things work, my engineering background. So why do we have an audio driver? What does it mean? What is the relationship with the hardware? What is the relationship with the software? Or what carries out the digitization of a signal, right? And how we can go back. What chip is doing that? What kind of mechanism is implemented, right? All of these steps, in my opinion, are fundamental not to treat science or engineering as science fiction, right? Oh yeah, this does this because it does, right? It's kind of magic. It's a black box that does this. No, if we know all the steps, the theory and all the steps, at least we understand, rather than knowing everything, but we understand the main key points, key frames, then learning DSP and programming becomes easier. And this means that maybe you don't necessarily have access to a programming background, a generic programming background, as I had. In engineering school, I started with C, and we were typing lines of code in a text file and then running a compiler, linking, running, and testing. And it was a hello world and blah, 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 right? Or enter a number between 0 and 10, wrong or right. Not exciting, but fascinating. Some students come and don't have this kind of background, but if they know exactly what audio is, it's not that complicated to wield and harness programming and computational logic to synthesize and process samples, basically. It all boils down to that. And know all the parameters, what they do, what they entail in terms of the resulting outcome. So this is basically my philosophy, starting from the very low-level functional and theoretical basics of things, and then switching to a practical understanding of the implementation of the SPM program.
Okay. And just out of curiosity, then, how do you test that these students really not only know, but also understand these subjects?
Well, that's a good question. It's a question that it's an overarching question in pedagogy, right? We have assignments, midterms, projects. We have informal evaluations. We have private conversation with students. Luckily, our classes are kept small, so we have a very direct relationship with students, very human. So there are many ways to double check if students truly understand. And of course, they understand and then they forget. Oh, it's always the case, right? We are trying to push too many things in their brains. They're amazing brains, but still, of limited capacity. We all know that. I do one thing in my life, audio, right? So it's easy for me to remember everything, more or less everything that I do. But they are taking classes from all over the place, right? Especially here in the United States, you have electives from all over the place. Math, engineering, philosophy, School of Business. I have so many students coming from the School of Business. So, especially in the introductory classes. So the idea is that it's challenging for them. We try to double check that they understand especially through experiential learning. So if the experience is active, it's more likely that they truly understand rather than memorizing, which is terrible, of course, because they put in practice what they need to know. And then we know that the following class, the 2000 level class, cannot start exactly where the previous one ended. You need to have a big overlapping so that they remember what they were supposed to know and everything is more smooth, and also they don't feel threatened, right? Oh, you don't remember this, so you're not capable of this. This would be terrible. No, it's okay. You don't remember this. It's fine. It's not great, but it's okay. It happens, especially at the beginning of a class.
Okay, thanks. So I'm curious because you also mentioned that you have students coming from different backgrounds to your classes, but in today's world, do you think that people have to go to a university or need to get a degree to learn digital audio signal processing? Or is it possible, let's say, for a musician or for a programmer who's not involved in audio to learn DSP on their own?
You can definitely learn DSP on your own. It's a fantastic experience. I especially with the internet, and YouTube is fantastic for this. You have so many, not just lectures, maybe not many lectures, but you have so many experiences and talks. The audio developer conference is these amazing talks, right? From musicians to developer. And they link to GitHub repos, or you can find articles on Hackaday. It's amazing. And sharing this knowledge is fantastic. And also, large language models, they somewhat work well to funnel this knowledge. So maybe it's difficult to find these resources. You can use a large language model, being careful and double checking everything, of course, but to have access to kind of a distilled version of the large information that is available out there. So absolutely, you can even land jobs in audio without having any formal audio-related degree. It's totally fine. If you have technical skills on the ground, because you learn it on the ground, and you have a passion for audio, and you can prove, by means also doing personal projects, that you have a professional approach, or let's say solid approach to development and testing or whatsoever, even creativity, that's totally fine. And as I said, the internet is fantastic for that. And remember, I told you, when I started at Queen Mary, my postdoc, I didn't know anything about embedded audio. I read a lot of papers for sure, but I didn't learn how to program embedded audio from papers. It was more about all these amazing resources that were shared online.
Cool. So in this vein, are there any books that you especially recommend for learning DSP? Because you mentioned the online resources. So, are there any very specific ones that you would recommend?
Of course, I like Andrew's book. Andrew McPherson and Josh Rees wrote this book a few years ago called, I think, Digital Audio Effects, it's called. And it's really good because it's not just about effects. It's really about audio programming in general. You truly understand the relationship between all the parameters of digitization, how they impact the outcome of algorithms, and why some algorithms need to be approached in a certain way or another. And also not just taking into account the engineering side, but also the mathematical side. Well, the model, how it is implemented, and how it reflects the functional behavior of the engineering that is underlying the actual running, like the real-time aspect of this implementation. So that's a very nice book. Very well written, very well organized. I really like it. But I don't use books in my classes. I typically create my own material, taking inspiration, of course, from several sources, including some books. So I cannot recommend any other book, let's say, that is as good as this one, because probably this is the one that I use the most as a reference.
Okay, cool. And speaking of your resources, are maybe your teaching resources available online somewhere, if it's possible?
So right now, no, for a reason. I didn't have any time to organize them. Of course, there are mistakes in what I teach, as usual. You discover, you go back every term, you go back, you reassess your content, and You see, I mean, this is not really correct. I mean, this line may be interpreted in a way that is incorrect, or this is just incorrect. I fumbled. But that's not a problem. It happens even in books, right, when they are published. The main problem is time, like organizing everything in a way that is accessible. I mean, I had barely enough time to complete the material per each semester that, it was impossible for me to actually make it suitable for online access. By the way, quick anecdote. The amazing real-time DSP lectures were possible because of the pandemic, in a sense, right? Because there was this necessity to shift to online teaching. This is something that Andrew told me. So there was an intent already happening, but then this shift helped the actual concretization of this idea. So no, not now. So my material not, but my next year's target is to have to start a publication of a book that is actually describes one of my classes. So
Awesome.
Contains the material in a more organized way, and also more, let's say, advanced way. Also, in the sense that it's not just for my pool of students, but it can also be useful for other types of students. So it contains more challenging topics sometimes for people that are not necessarily graduate or undergraduate students. Maybe they are PhD students, right? People that need a more complete understanding or explanation of things. And we'll see what happens. I'll spend most of the summer and the next fall to make this happen. It's about actually analog electronics, though, for music, for sound. So not the DSP part. There are some good books in digital signal processing for audio, I think. I had a lot of troubles finding good materials for analog audio. So that's why I decided to focus on that outlet.
Super. I mean, I'll be curious to check out this book for sure.
Fingers crossed. We'll see if it gets to the finish line.
Okay, and maybe the last question that I have on the topic of teaching, because as I understand, a part of your student comes, without any technical background. And what's the challenge and maybe your approach to this challenge of, teaching them the technical side of music?
I want to emphasize that the students that come with no technical backgrounds are the ones that are in my intro to music technology class. Mm-hmm. So that is the only case.
Okay.
And in fact, I teach with no assumptions. I assume they don't know anything, which is a good assumption in most cases. And the students they know sometimes are confused because audio engineering is confusing. The information that we find in everyday life is confusing, counterintuitive, and sometimes either even it's contradicting itself. Right? For example, concept of volume is very, students know what it is, but when you actually understand what loudness and level is, it's just okay. Different perspective on what I came with a different perspective on the baggage of knowledge I came to class with, right? Mm-hmm. So those students, yes, they are nurtured, they're spoon-fed in a sense with all the basics with no assumptions. The other challenge that I have in upper electives is that since I teach in a very interdisciplinary environment, students come with technical backgrounds that are different. Mm-hmm. Some are very strong in music theory, or in sound in general, sound design. And some students come with very strong background in computer science, programming, and electrical engineering. And so it's difficult to teach a class that is appealing and say meaningful to everyone, right? Mm-hmm. And again, the idea is to provide. To try to put yourself in the heads of every student, and make sure that you fragment the class, showcasing the interdisciplinarity or leveraging the interdisciplinarity, let's say, at every slide. What I mean is that at every step should focus on a variety of topics that are across the full spectrum, not just engineering, not just computer science, not just sound, not just music, but try to at least iterate across them as much as possible so that you provide hooks for all the students to be really enticed. Problem is not knowing. The problem is be enticed, be captivated by the class, right? And this gives you the fuel to, fill the gaps and learn things that you don't know, even when they are challenging. But if you're bored, because this is too far from your vision, then there's no escape, right? Maybe the smartest student in the world, but if there is no motivation, or you kill that motivation as a teacher, that's terrible, right? So try to play this game, right? Having a lot of cards on the table all the time and really demonstrate them that it's so cool for them to learn this stuff, no matter their background.
Okay, cool. Thank you.
Cheers.
Okay. Switching topics now a little bit. You said that you are involved in this community of new interfaces for musical expression, if I may say so. And if I'm not mistaken, you're the first person on the podcast from this community.
Nice.
So I'd like to take this opportunity, if you could share more about the idea behind NIME and the associated conference.
Absolutely, yeah. NIME is a worldwide community that gravitates around this yearly conference that happens all over the globe, every year in a different continent. And it's a community of researchers, not necessarily from academia, it can be both academia and industry, but also musicians, scientists, creatives, artists, whoever is interested in new interfaces for musical expression. Not just instruments, right? It's just anything that can be a vehicle of musical expression, even a sound installation, interactive installation, right? It's not an instrument per se, but it's still under the umbrella of NIME. And it's a very interesting community because it basically branched off of the CHI community, that is the Conference of Computer-Human Interaction. Mm-hmm. So it was born, I think, in 2001 as a workshop, a satellite workshop, where people from this CHI community decided to discuss how human-computer interaction pans out in the context of musical instruments and, in general, devices that make sound. How do we use them, right? Because there's this big discourse about HCI. How do we interface with computers? And computers is basically everything nowadays, right? And musical instruments now are kind of computers. So back already in 2001, this question was important for a subset of this community. And then we quickly realized that there are so many things or paradigms that must be modified compared to a regular traditional HCI, because music and musical instruments are so unique, right? Mm-hmm. And that's why it became its own community, its own conference. It's not under ACM; it's completely independent. So the idea is to really focus on a unique problem. Let's say it's not a problem, but a unique context with its own challenges and opportunities. Often, in contrast, I want to emphasize this with standard HCI paradigms. For example, interaction should be easy. No, interaction with musical instruments must be extremely challenging. Otherwise, there's no path to virtuosity, embodiment, expression. Otherwise, it's a toy. It's not a musical instrument. That's fine. It's good for toys to exist, musical toys, but we also want to understand how to get to the violin, right? The next violin, let's say.
Hey, I think that's super interesting. And in this frame, could you share what were your contributions to this field?
Absolutely. So my first contributions were about understanding how we make music and experience music in virtual reality back in the 2010s. And it was a fairly different paradigm compared to what most of the community attendees or participants were focusing on at the time. And then I switched towards this hackable instruments idea. Mm-hmm. So changing the way we design instruments to allow for different types of appropriation and also, creative practice. And then I started really focusing, and this is really my take, I think, on this NIME community, really focusing on very promising technologies that were not born in the context of audio and sound, but promising in the context of, when transferred, let's say, to the context of a musical expression. So how can we harness the power of such innovative technologies that were not designed for music and sound, but they can definitely have the potential to be transformative in that domain? And this is exactly what I did since basically 2016, 2017, working on physical models, GPUs, and now working on phones. Specifically now I'm working on phones to deploy deep neural networks that harness audio, and trying to understand how we can really make musical instruments and leverage these technologies, and how these technologies should be modified to kind of line up with the expectations and the paradigms that exist in the context of interaction with musical instruments.
Okay, cool. Yeah, and definitely that'll lead to kind of a, let's say, democratization of these digital the digital musical instruments, like in the sense that you're also not only designing new interfaces, but you're also enabling other people to easily create new digital musical instruments. I think it's pretty cool. So
if I may, this is a very good comment. I would say at this point, all my research gravitates around open source, and that's exactly what I like about it. It's not just publishing a paper, going to a conference, talking to those 100 people that are in my field that know exactly what I'm talking about. It's really about writing code that exists on the internet, or writing even a paper that describes a vision that is accessible to everyone, right? Not necessarily I would say, I don't want to see academia as a closed environment. There's a better word that I'm missing right now. Probably will pop out as soon as we finish this conversation, but whatever. I don't want this to be an elite, right? It shouldn't be an elite. What the outcome should arrive to people in a way or another. And I think that through open source, by sharing code, by sharing also views and perspectives, we have an impact that goes beyond the typical research outcome. That is, you discover something, gets to the public domain, and then people run companies and make make money off of that, right? They design products and sell them. It's more about sharing this knowledge and these mindsets to people at large.
Okay, cool. And still in the same vein, I also understand that you're creating interactive audio-visual installations and perform live with the instruments you designed. So is it possible somewhere to see your work in this area?
Complicated, because I don't consider myself a musician and performer. I consider myself first a researcher, right? So I say I'm an engineer and a musician, but actually I'm a researcher and teacher at this point, educator. But the musical outcome, and creative outcome is still there. I just don't advertise it. I don't document it a lot. So the best way to see my stuff is to go to the conference where I perform and or set up my installations and stuff like that. Why do conferences? Because I this is what is my position is evaluated, right? And the creative outcome, if it is presented at a conference, is considered in line with the expectations. Right? Not that I don't like festivals or anything like that. Is that time is limited, so I need to really narrow down and nail, let's say, the targets that are expected by the people above me, right? And so conferences, yes. So for example, last year I was at the International Computer Music Conference 2024 in Seoul, and I had my installation running there for a week. A few years ago, I was at SIGGRAPH in Vancouver, which was awesome. We had a performance in front of a lot of people. It was 1,800 people. It was very exciting and scary, especially because we were playing the Hyper Drumhead, which is not a product. It's just a research instrument, so it may break. It isn't fantastic, but it may. And yes, I don't record music. I used to, but I don't do this anymore. And all the stuff that I recorded is not online anymore. So I'm a little bit shy in a sense in that regard. So if the outcome lines up with my academic expectation, yes, no problem. I'm all there. But for what concerns my personal creative outlet, difficult. Just maybe on YouTube, there is some stuff on my YouTube channel. There may be some stuff, but it's not curated. It's kind of old.
Okay, so that now the people have another good reason to go to one of these conferences to see you perform live. Yeah.
Yes. Yeah. Absolutely.
So now at the end of the interview, I wanted to switch to kind of lightweight questions that should be fun and snappy. So my first one is: have you developed a kind of fixed approach on how you do research? Like a daily or weekly routine, times of the day where you can focus most, etc.
Sure. Everything that revolves around my teaching schedule. When I don't teach, when I don't prepare classes, well, that's the right moment to carry out research, regardless of the time or of the day of the week. Jokes aside, I like to save up long slots for research. So rather than fragmenting research, I like to, say last year I had a coding Friday. So my Friday was all about doing research in terms of coding and development. Mm-hmm. So checking out my current version of my code for a specific project, reading technical publications about how to move forward, comparing with GitHub pages and stuff like that. In the summer, I do a lot of literature review because I don't have time during the rest of the year typically because I don't teach in the summer. So I allocate a lot of time to that. And that, of course, that leads to the writing side of things back in the fall and the following spring. So it really depends on my teaching duties. It takes up a lot of time, so I organize everything around that. I used to be a night coder and a night music maker. I can't do that anymore because I have classes in the morning, right? So I reorganize my schedule so that it's more, let's say, adult in a sense. I feel more of an adult with regular bedtime curfew and stuff like that.
Okay. So I also used to do a lot at night, but after I graduated, I cannot do it anymore. I just when I pull a full nighter, then I have like 2 days of my life basically. So it's more of a risk than an opportunity.
Exactly,
I totally understand. But at the same time, I know I had an amazing professor who was, I think, doing research or programming up to 4 a.m. in the morning because at night his kids were asleep. And then he made it to 8 a.m. lecture and was very energetic throughout the rest of the day. So there are people that manage them, and I really envy those people.
Well, I would label this the mysteries of fatherhood.
Yeah, maybe that's the thing. Okay, the next question is: which tools currently help you in research the most?
Yeah, since my PhD years, Google Scholar, of course, has been an incredible tool. And through the university, not just this one, but all the universities I worked for, we have access to some, repos that are behind paywalls, which is good. So Scholar works even better in those cases because you're logged in, you have an IP address from a specific institution, so you have access to extra papers. That was the past, though, maybe the past. And the present, of course, as I mentioned earlier, large language models. They're really good at retrieving paper titles now and citations. They were not good at this before, like last year. Now they can do that. I remember this paper that it was about this, blah, 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 but I don't remember who, when, why. And it's, in many cases, it nails it. I'm very, very impressed. What else? What do I use? I scout a lot at GitHub. Typically, there are publications with links to GitHub pages and repos. and it's fantastic. Like the possibility to replicate a piece of code, an application, it's incredible. That's what I tend to do. I tend to always combine code with publications myself. By the way, remember when I was at Queen Mary, there was this first idea of replicable research. So the idea of sharing data sets, sharing code. And it was not about machine learning at the time. It was just in general, any kind of data set that was used. And now, of course, this is the practice, like the regular practice. Hugging Face and Kaggle, all these incredible repos. Everything is in there. So we have to say big thank you for the people that were presciently understood the importance of not just having code, but also data tied to it.
Okay, cool. Thank you. And I think people that are more research inclined will definitely take advantage of the tools that you mentioned. And I wanted to ask, when you do research or programming, do you listen to music?
When I do programming, sometimes I do that, especially if it's just the banal implementation of stuff, right? So you know what I mean. I guess you know what I mean, right? So you don't have to think about anything. You just can translate everything into code. You know already, right, what to type. So yeah, that gives me the flow. And if I stumble upon a little problem, a good background music helps a lot. I like instrumental music for that, specifically electronic instrumental music. Sometimes kind of a more darker sounds, but sometimes also upbeat, depends on the mood. But when I'm grinding code, I'm really trying to solve a problem that I cannot wrap my head around. Or when I'm reading papers or doing research across internet links, I can't listen to music. I found it a little bit distracting, which is a little bit of a disappointment. But I remember when I used to make a lot of music, I was using all these programs, these applications. I was not listening to music while I was doing that. So I'm kind of used to interface with technology without a musical background. For different reasons, but it is what it is.
Okay, and because I'm also fan of electronic ambient music, and including dark ambient. So, are there any artists that you recommend in this genre?
Okay, I can say one I listened to recently, Devin Townsend, the former vocalist of Strapping Young Lad. He has a metal career, but he also has these instrumental albums. Specifically, the last one, I don't remember the title. It's pretty good. It's back there. I mean, you can leave it back there, and it's quite good. I really like it.
Cool. I need to check it out then. Okay. And how do you rest and recharge after work?
I do a lot of physical activity, like every day, almost every day. Always been like that.
Okay.
Easy peasy. Yeah, of course. I have friends, I have a social life, but the actual battery recharging mechanism happens in the gym or whatever I do physical activity.
Okay, great. Okay, Victor, thank you very much for this interview. I really, really appreciate your time and expertise and, all the amazing things that you've been working on and sharing them with the viewers. I think this is really the embodiment of a teaching spirit to share so much knowledge. So my last question is, if someone wanted to contact you, where do you recommend they go?
Well, I have an institutional page that describes who I am and talks a little bit about me. It's under the College of Arts, Media and Design in Northeastern. So if you look for my name and College of Arts, Media and Design Northeastern, for sure you'll find it. There's my email there, so happy to connect with anyone who is interested. Otherwise, you can find me on GitHub, of course, Victor Zappi on GitHub. Some stuff there, old stuff, newer stuff. Be my guest. And also, since you thanked me, I want to thank you because you really inspired part of my latest research. And you have a lot of knowledge to share. And you said you're a teacher. You're an educator. And the fact that you are active online, but also I met you at a conference it's really amazing. It shows how much you care and how concrete your interest and passion for audio and development is.
Thank you. Thank you so much for these kind words. And I hope our paths cross again
for sure
at one conference or another. So thank you once again, and I wish you all the best for all your future endeavors.
Thank you very much.
All right, everyone. That was Victor Zappi, an assistant professor of music technology at Northeastern University and a researcher on music instrument design. Thanks a lot, Victor, for your time, for taking the attention to answer all the questions and give a ton of helpful tips to everyone interested in audio programming and audio research. To you, dear listener, all episode notes are available at thewolfsound.com/talk029. Once again, it's thewolfsound.com/talk029. And if you enjoyed this episode, please consider giving a 5-star review on Apple Podcasts and Spotify. And if you're listening on YouTube, give a thumbs up to this video and subscribe to the channel. Finally, let me know, do you plan to check out the LDSP C++ framework for low-level audio device control on Android devices? Let me know in the comments. I'd be curious to learn. Finally, if you want to learn digital audio signal processing, check out my DSP Pro online course at wolfsoundacademy.com/DSP-Pro. Thank you for listening and see you in the next one. Take care.